All right. So the first part of this problem is to balance the reaction using whole numbers. So first you want to balance the charges. You can see we have 3 plus on this side and 2 plus on this side, where these guys are neutral. So I want to add a 2 there and a 3 there. But then the atoms are not balanced, so I'm just going to bring it down here. So I want to add a 3 here, so that we have 3 moles of tin here and 3 moles of tin there, and then a 2 in front of the iron, so we have 2 moles on each side. So now the atoms are balanced and the charge is also balanced. We have 6 plus on both sides. Okay, the next part of the problem is to write out the half reactions and indicate whether they occur at the cathode or the anode. So the first half reaction we can do as the, we want to look at the iron. So we just take out all the terms with iron in them. So I left a blank because we get to neutral, so we're definitely going to be adding electrons here. We start out with a +6 charge and we want to end up with a neutral charge. So we want to add 6 electrons. So that's one half reaction. The second half reaction, we want to take all the things with tin in them. So that's this. All right, and here we start with neutral, and then on this side we have 6 plus, and so in order to make it neutral, we want to add 6 electrons on this side. Awesome. So now we need to identify which is the oxidation and which is the reduction. So here we are going from a 3 plus charge to 0, neutral. So we're getting more negative, and when you get more negative, that means you are adding electrons, and addition of electrons means it is a reduction. Down here, we are going from a 0 charge to a +2 charge, so we are losing electrons, and when we lose electrons, we are doing an oxidation. Awesome. All right, and that will tell us which half reaction occurs at the cathode and which is at the anode. And we know that the cathode reaction is the reduction, and the oxidation will happen at the anode. Awesome. And then the last part is we want to calculate the standard cell potential, so that's this guy, and we have an equation for that. It equals potential at the cathode minus potential at the anode. Awesome. And we can look in our table of the standard potentials, and the table has everything as a reduction, so it will have this equation flipped, so that it's a reduction, not an oxidation. And what you do when you look at that table is you get, let me check the numbers, you get 0.77 volts here, and then you get negative 0.14 volts. Awesome, and since we're subtracting a negative, we're actually just adding these two together. So we get the final potential to equal 0.91 volts. And that's the end of the problem.